Hello everyone. Today in the same section 3, we are going to move on lecture 6. So section 3, we are in basic computational operations used in data analysis. Under that, in the previous section, previous lecture 5, we have seen about the basic mathematical operations like addition, subtraction, and multiplication, division, module. So those things we have seen in the previous lecture 5. And the next thing is increment and decrement operators, universal functions in data processing. So these are the advanced techniques that we must know in data analysis. What is the purpose of increment and decrement operators in data analysis? So as a beginner, we might have the basic knowledge that whenever you are going to analyze some data, we have to move on to the next, that is increment. Sometimes we have to go back and analyze the previous data also. So it's not sometimes, many times. Because in data analysis, we are going to analyze the past. So sometimes we have to decrement and do the analysis. So particularly in data analysis, most of the people are using Python. Here, increment and decrement operations are common in programming and are frequently used in data analysis. For what kind of task we have to use increment and decrement? Such as index iteration like row counting, looping through data, and value updation. But the thing is, Python will not support the traditional increment operator, plus, plus, and minus, minus operators. But an increment and decrement operation can still be performed using plus or equal, minus or equal to operators. So in the Python, it will not support for the native increment or decrement. Here you can perform the increment operator using x equal to x plus 1 or x plus equal to 1. Like that, you can perform the increment operators. From the screen, you can understand what syntax we have to use in Python for increment. The same way you can see for decrement also. Either you can subtract or you can use this new operator like x minus equal to 1. Here we have given the example x equal to 10. When you are applying this operator, automatically it will be increment to 11. In the same way, minus means when you want to decrease, then you can apply this operator and it will become 10. From the 11, it will be it will decreased to 10. And where we are using that increment and decrement operator, most important thing is loop. So when we are entering into the data analysis, most of the time we will use loop. So at that time, increment and decrement operator will place the major role. For example, you can see it here. And one more example, counting records, matching a condition. For example, here you can see that we have taken the data frame, that's the input data, with the score. So here we have the score 85, 40, 67, 90, and 35. So always we will start the count from 0 and we will set the condition from the score data. If the score is greater than 50, then we have to move on to the next, that is increase. So at that time, if the condition is true, then we have to increase the value. Then finally, we have to print how many number of students are passed. So these are the main thing of increment and decrement operators. And the next thing is we're going to see about the universal function, that is U function. Mostly we will use in NumPy. That is one of the libraries that I'll explain in my next course. What are U functions? Universal functions are a fast, which is the element-wise functions, which will be provided by the NumPy libraries, which is one of the library in Python, which operates on arrays and it will perform the vectorized operations. So instead of working in a single array, the universal function will be applied on the entire arrays without writing explicit loop. And that can avoid the need of Python loops and are highly optimized for the performance. What are the key characteristics? Here we will see the key characteristics of universal function. First thing is speed, which will be more faster than using loops, and vectorization, which will be applied the operations on entire arrays. And the simplicity, the syntax, if you see the syntax, it will be very easy and you can read it easily. And consistency, we can handle broadcasting and array shapes efficiently using the universal function. The categories of universal functions, we have different types of categories in universal function. First thing is arithmetic universal function. So instead of applying the addition, multiplication, division, whatever we have seen in the basic operations in the previous section, means the lecture 5, if you apply that function one by one, the time and space complexity will be very high. And the computational performance also will become low. So that's why the Python libraries having this universal functions, you can use it easily and you can improve the computing also in a speed way. So here you can see that what are the arithmetic universal functions available in data analysis. The function called np.add x comma y. So this is the element-wise addition. So for example, add 1, 2, 3, 4, automatically it will give you the output 4, 6. If it is a basic mathematic addition operations, we have to perform add 1 plus 3, 2 plus 4 like that. But in the NumPy library, using this universal function, you can directly perform that addition operation. And subtraction. Here you can see that NumPy, that is np.subtract of x comma y, will give you the output. If you give the x, y input value, automatically it will give you the output. And the same way, multiplication, element-wise multiplication and division. Next thing is mathematical universal function. So this here you can apply square root and exponential, then log, trigonometric, and rounding operations. For all these things, directly you can use these functions. Then comparison universal functions. In the previous lecture, we have seen about the basic comparison operations, greater than, less than, equal to, maximum, minimum. Here using this function directly, it will compare whether x is greater than y or not, whether x is equal to y or not. Likewise, the element-wise maximum value, minimum value will be taken care by universal function syntax. And logical universal function, that in the previous lecture we have seen about and or not. So that element-wise logical and or and Boolean functions also will be introduced in universal function. Here you can see the syntax np.logical and np.logical underscore or np.logical underscore not of input. So if you simply give the input, it will give you the output. The common universal function categories are arithmetic, as is that addition, subtraction, multiplication, division, and trigonometric, sine, cos, tan, and exponential and log, exponent, log, log 10, statistical methods, mean, standard deviation, and variation. Then finally, the comparison universal functions also available, maximum and minimum. The example, we can see that for arithmetic, we are importing that NumPy from the library that I'll explain in the coding part in the upcoming courses. Here I'm just telling you the syntax. Here you can see that A equal to np.array 10, 20. One array we are giving, in P, one more array we are giving. Simply np.add will add these two arrays. Here you can see that. In the same way, you can perform np.multiply. So examples, here we will see the example using for the statistical method. So here you have the data array, the data in the format of array. Simply by mentioning np.mean of the data, you can find out the mean value. Likewise, the standard deviation also np.std of that input value will give you the standard deviation. You don't need to apply of any mean function formula, standard deviation formula. Directly you can perform this using these functions. Likewise for exponential also, we no need to type the equations. Using this NumPy function, you can apply. And for trigonometric functions, angles we can able to find out easily using np.array, np.sign of the angle, that is the input. And comparison operations, max value, np.maximum of input, mean the input 1 array and the array 2, that is the input 2. And it will compare and give you the maximum value as a separate array. What are the benefits of using this universal functions in data analysis? First thing is speed. The vectorized operations are much faster than the Python loops. And simplicity, code is shorter and more readable. And efficiency, it handles large data sets efficiently in memory. For example, if you want to analyze the data will be, the data set will contains the large amount of data. At that time, you cannot perform the basic operations as a one-by-one function or using loops or using a separate equations. That is very difficult for the data analysis purpose. So at that time, you can use this universal function. It will be give you the easiest way to compute the data analysis easily. Thank you. In the upcoming, we will see about the advanced function that we must know for data analysis purpose. So in next lecture, we will see that.